Top 10 Amazing Women in Science Who Should Be More Famous. Hello viewers, welcome to another exciting edition and thanks for watching. Today we shall be talking about the top 10 amazing women in science who should be more famous. Studies have shown that women are discouraged from or becoming less interested in entering the fields of science, technology, engineering and math (STEM) beginning at a young age. And according to the Pew Research Center, women remain underrepresented in engineering, computer science and physical science. But despite challenges of gender discrimination and lack of recognition in the scientific community, countless inspiring women in these fields have made historic contributions to science and helped advance our understanding of the world around us. Many were not recognized in their own lifetimes, but their achievements have helped generations of female scientists to come. If you are new here, welcome. Be sure to subscribe and turn on your post notifications so you don't miss any of our amazing videos. These women from wide areas of scientific fields practiced and contributed a lot when science was more of a man's thing. These are top 10 amazing women in science who should be more famous. Number 10. Jane Goodall, British ethologist. Attitudes towards wildlife and conservation have transformed dramatically in recent years thanks to the research, dedication and compassion of extraordinary scientists like the chimpanzee aficionado Jane Goodall. From childhood, Jane yearned for a life among African wildlife away from the war-stricken England she was born into. Unable to afford university, Jane settled for a job as a secretary, and by age 23, Jane had saved enough money to journey to Kenya, where she met renowned anthropologist and paleontologist Dr. Lise Leakey. Leakey, astounded by Jane's enthusiasm and knowledge, embarked alongside her on an investigation of wild chimpanzees in Gombe at a time where the concept of a young woman cohabiting with wild African animals was preposterous. Her compassionate nature gained Jane the chimpanzee's trust, and she witnessed them eating meat and using tools, behaviours that disproved the existing assumption that chimpanzees were vegetarian. In 1965, she defied the odds to become one of the first to accomplish a PhD despite lacking a degree. Because of this, however, many scholars disregarded her credibility. Her success earned her funding from National Geographic, enabling her to establish the Gombe Stream Research Center. Throughout her phenomenal career, Jane Goodall published numerous books including the revolutionary work The Chimpanzees of Gombe, Patterns of Behaviour, and founded pioneering research establishments such as the Jane Goodall Institute for Wildlife Research, Education and Conservation. Upon learning of the deforestation and cruelty devastating global wildlife, Dr. Goodall turned her experienced hand to conservation and now travels extensively, inspiring the next generation to proactively safeguard endangered wildlife. Number 9. Emmy Noether, German mathematician. Amalie Emmy Noether was a German mathematician known for her landmark contributions to abstract algebra and theoretical physics. She was described by Pavel Alexandrov, Albert Einstein, Jean Dieudonné, Hermann Weyl, and Norbert Wiener as the most important woman in the history of mathematics. As one of the leading mathematicians of her time, she developed the theories of rings, fields, and algebras. In physics, Noether's theorem explains the connection between symmetry and conservation laws. The extent and significance of her work cannot be accurately judged from her papers. Much of her work appeared in the publications of students and her colleagues. Many times a suggestion or even a casual remark revealed her great insight and stimulated another to complete and perfect some idea. Number 8. Esther Leatherback, American microbiologist. She developed basic techniques that have gone a long way towards helping scientists understand how genes work. Her contributions include the discovery of the bacterial virus Lambda, the transfer of genes between the bacteria by specialized transduction, the development of replica plating, and the discovery of the bacterial fertility factor F. Esther attended Evander Childs High School in the Bronx. In 1942, at the age of 24, on completing her undergraduate degree, Esther was awarded a distinction, and 2 years later she won a fellowship to Stanford University to take a master's course in genetics. In 1945, Esther spent the summer studying with Cornelius Van Niel at the Hopkins Marine Station at Stanford University. Esther's first major achievement was her discovery of the lambda phage, when completing her doctorate in 1950. In addition to discovering the lambda phage, Esther invented the replica plating technique. Devised by her in 1951, this method enables scientists to replicate bacterial colonies on a series of agar plates with exactly the same spatial configuration. Joshua, her husband, received the Nobel Prize for Physiology or Medicine for discovering that bacteria can mate and exchange genes. Much of this could not have been achieved without Esther, who was more adept at experimental work than he was. Her isolation of the lambda phage and her discovery of its genetic replication process, as well as her innovative replica plating technique, were clearly crucial to Joshua's research. Number 7. Grace Hopper, American computer programmer. The nickname Amazing Grace was not bestowed upon Grace Hopper without merit. An intuitive mathematician and computer programmer, she spent her early years studying at some of the most prestigious institutions in America, ultimately becoming one of the first women to achieve a PhD in mathematics. When World War II descended, Hopper followed in her grandfather's footsteps, leaving her job teaching maths at Vassar College to join the US Naval Reserves. She was directed to Harvard University to learn to program the Mark I, the first functional computer. When technology had advanced to the Mark II computer, Hopper famously coined the term debugging when the programming team removed a moth that was disrupting the computer's processing. Grace endeavored to make computing accessible to the general public, first and foremost through the development of a comprehensive computer language, COBOL, which was based on English words rather than binary codes. Twice she tried to retire but ended up continuing to work into her 80s, making her the US Navy's oldest active duty commissioned officer and earning her the Defense Distinguished Service Medal. Number 6. Maria Telkes. She studied physical chemistry at the University of Budapest, graduating with a BA in 1920 and a PhD in 1924. She became an instructor at the institution in 1924 but decided to immigrate to the United States after visiting a relative who served at the time as a Hungarian consul in Cleveland. In 1925, she accepted a position as a biophysicist for the Cleveland Clinic Foundation, where she worked with American surgeon George Washington Serial to create a photoelectric device that recorded brainwaves. During World War II, while working for the US Office of Scientific Research and Development, she created a solar distiller that vaporized seawater and recondensed it into potable water. In 1948, her design for the world's first home heating system, based on the capture of solar energy, came to fruition with the construction of a house in Dover, Massachusetts, that made use of solar collectors and Glauber's salts for heat storage. Number 5. Margaret Pierre, French physicist. She is a student of Marie Curie. Margaret Pierre discovered the chemical element francium in 1939. Francium was the last element ever discovered in a natural source. In 1929, she qualified with a chemistry diploma from Paris Technical School of Women's Education. She received a PhD from the Sorbonne in 1946. Pierre spent a decade shifting out actinium from all the other components of uranium ore. Pierre first noticed that the actinium she purified was emitting unexpected radiation. After further study, she was able to isolate this new element, which she named francium for France. Francium was found to be the least stable of all natural occurring elements. This is something that could only be done with exacting technique and years of experience. The fact that the lab assistants could prepare the samples and make a discovery shouldn't be surprising, but the fact that she would get the credit is. Number 4. Cecilia Payne-Gaposchkin. British-born American astronomer Cecilia Payne-Gaposchkin discovered that stars are made mainly of hydrogen and helium and established that stars could be classified according to their temperatures. In her PhD thesis, published as Stellar Atmospheres 1925, Payne used the spectral lines of many different elements and the work of Indian astrophysicist Meghnad Saha, who had discovered an equation relating the ionization state of an element in a star to the temperature and definitely establishing that the spectral sequence did correspond to quantifiable stellar temperatures. Payne also determined that stars are composed mostly of hydrogen and helium. However, she was dissuaded from this conclusion by astronomer Henry Norris Russell, who thought that stars would have the same composition as Earth. Payne received the first PhD in astronomy from Radcliffe College for her thesis, since Harvard did not grant doctoral degrees to women. Astronomers Otto Struve and Valentina Tereshkova later called her thesis undoubtedly the most brilliant PhD thesis ever written in astronomy. Number 3. Valentina Tereshkova, Russian cosmonaut. When it comes to the space race, although the USA were the first to land a person on the moon, there were a number of other space attempts they were beaten to. There are 3 cosmonauts that head the Soviet Union's Hall of Fame: Yuri Gagarin, the first person in space; Alexei Leonov, the first person to spacewalk; and Valentina Tereshkova. While still a textile worker, Tereshkova was selected from 400 applicants because of her skill at skydiving, proletariat background, and worthiness for the role. And on the 16th of June 1963, she made her space history by becoming the first woman in space. She orbited the Earth 48 times in a mission that lasted nearly 3 days, and at the age of only 26, remains the youngest woman and the first civilian to visit space. After her return to Earth, she continued to inspire future generations as a high-ranking member of the government, representing Soviet women in numerous positions on the global stage. But it is still space that inspires her, still wishing to fly to Mars, even if it is a one-way trip. Number 2. Lise Meitner. Meitner was an Austrian-Swedish physicist. Her expertise was on radioactivity and nuclear physics. Lise Meitner and her long-term collaborator Otto Hahn discovered nuclear fission of uranium. Einstein praised her as German Marie Curie. Meitner is often mentioned as one of the most glaring examples of women's scientific achievements overlooked by the Nobel Committee. A 1997 Physics Today study concluded that Meitner's omission was a rare instance in which personal negative opinions apparently led to the exclusion of a deserving scientist from the Nobel. Element 109 Meitnerium is named in her honor. In 1947, a personal position was created for Meitner at the University College of Stockholm, with the salary of a professor and funding from the Council of Atomic Research. Number 1. Elizabeth Garrett Anderson, English doctor. Elizabeth Garrett Anderson was an outstanding and resilient woman whose plight and determination enabled other women to also achieve greatness. Having been inspired by successful women such as Elizabeth Blackwell, the first female doctor in the US, Elizabeth Garrett Anderson opted to contradict the submissive life she was expected to lead and become a doctor. Denied entry to any medical school, despite her respectable education, she was forced to study nursing alongside male peers whose objectives led her to dismissal. After Elizabeth qualified as a doctor through the Society of Apothecaries, they immediately implemented a ban on female entrance. The sexism and adversity Elizabeth faced only fueled her strength and resolve. Having taught herself French in order to study at the University of Paris, Elizabeth finally earned her medical degree. However, this was still not enough to allow her onto the British Medical Register, so she established a new hospital for women, which was to become the London School of Medicine for Women, where she was later appointed Dean. Her vocal campaign efforts eventually paid off, and in 1876, female entry into the profession of medicine was legalized. Even though she had retired from medicine, Dr. Anderson was still grinding down the patriarchy, becoming the first female mayor in England. She was influential to the suffragette movement and inspired her daughter, alongside many other intrepid women, to follow her esteemed footsteps and strive towards gender equality. The history of science can at times read like a list of bearded old men, but there have been many incredible and inspiring women like these ones, and we need to celebrate them more. Thanks for watching. If you did enjoy this video, don't forget to give this video a thumbs up, share with your friends, subscribe to our channel and turn on post notification.